So we are going to review collision. And then after we've reviewed it today, we're going to have a little look at it in more detail tomorrow. We're going to go deeper. But I didn't think it was fair to start testing your understanding of it without a quick review first. So Unit 2, Energy, Lesson 3, how do collisions show energy? And I've still got Angry Birds because it's still my favorite picture. What are we doing? Right, does anybody else like Pokemon? Because I grew up watching Pokemon, so I still think it's cool, but I realize that it might not be cool anymore. But I like Pokemon. This is a Pokemon. He's using a move called Brick Break. And why is that relevant to what we're doing, David?
For collision.
Mm-hmm. Oh, delicious coffee. Yes, collisions. Good. Thank you, David. So what are we going to do? We're going to review collisions and energy transfer. We're going to review energy transformation. I wonder if anybody could tell me what the difference is, or what is energy transfer? Lily, can you remember what energy transfer is?
Is and the energy move from an object to another.
Yeah, good job. So energy transfer is when it moves from place to place. Hopefully you guys remember that I used an analogy for money. If I transfer you money, then it goes out of my account, it moves from my bank account into your bank account. The money has transferred, the money has moved. Who can tell me what energy transformation is? And I want you to think about werewolves. Aisha, what's energy transformation? What does the energy do if it transforms? What does a werewolf do? Or what does a person do when he transforms into a werewolf? Does he move or does he change? If a person blah blah blahs into a werewolf, what are they doing?
They change.
What does his body do? Does his body stay the same?
No, it changes.
Yeah, it changes. So thank you, Aisha. So I used the analogy. Oh no, I forgot to turn off annotations. Be at home, stop drawing on stuff. Okay. I used the analogy of a werewolf because we know that a werewolf transforms in a full moon. And that means he changes, his body changes. So energy transformation is when energy changes type. I'll give you one example and then I'll ask somebody else for another example. When I play my saxophone, which I can see over there by the cupboard, I use the motion energy in the reeds and in my air, in my lungs. Motion energy, it transforms it into sound energy. I wonder if anybody can tell me another energy transformation. Maradona, can you think of an energy transformation?
No.
What about do you remember making the drum?
Yes.
Yeah, what did we do?
Take the seed and put it in a drum and hit it and see if it vibrates.
Yeah, we hit it. What happened when we hit the drum? Was it silent or
loud sound?
Loud sound. Okay, so if we hit it and then it made a sound, how is that an energy transformation?
Motion to sound energy.
Perfect. Yeah, thank you very much. Okay. Excuse me. Thank you, Maradona. Yeah, so we're going to look at energy transfer, energy transformation. We're going to have a look at collisions and speed. That's to do with the game that I'm going to show you. We're going to have a look at collisions and size. That's not to do with the game, but you'll remember that from our truck and our little car, which we'll see shortly. And we're going to have a look at collisions and mass. And that was to do with the particles. And it was also to do with the differently weighted balls that were sprung into the air. Speaking of springs, we're also going to have a look at potential energy and stored energy. And obviously by the end of this, because we've done it so many times, you're going to be little experts on collisions and how collisions show energy. So some vocab. Let's do a quick review. I'm going to pick some people. Who's going to tell me what a collision is? Goku. If somebody said, oh no, I had a collision in my car.
I think it is made like energy.
It definitely involves energy. Yeah. What if I said me and my brother were fighting and we had a collision and now both of our heads hurt? Katie?
It's when something hit each other.
Yeah, when they hit each other, when they crash into each other. It's an impact or a crash. Good. Okay. So if a collision, the noun, is an impact or a crash, what's the verb to collide? Ronaldo.
Yes.
Hello, Ronaldo.
Hello.
Ronaldo, if the noun collision means an impact or a crash, what does the verb mean? What does to collide with something means? What does your foot do to the ball?
It's a ball.
Yeah, it hits it. Good job. So it means to hit, impact, or to crash into. So if two things collide, they bump into each other or they hit each other. Potential. Potential's tricky. Who's going to give you potential? Viet Hung. Viet Hung, what is potential?
Potential means
Something that could.
something that could be.
Yeah, good job. That was a really tricky one. What it could be or what it could become. Thank you, Viet Hung. And so then potential energy is energy that can what? Harry Kane.
Well, potential energy is what it could be or become.
Yeah, so it's what the energy could turn into, what it could become. So, so Harry Kane, potential energy is stored energy that can become motion energy. And somebody else is going to give me an example of stored energy. Maybe Courage.
Yes.
Hey, Courage, can you give me an example of something with stored energy? Do you remember the watermelon video?
Yes.
Yeah. So what did she use? What did she pull back?
She used string.
Oh, it's nearly string. So it's like it's a rubber band or an elastic band.
Yes.
Yeah.
I
And I've got you mute. Neymar, with your awesome background. Hey, Neymar.
what?
So, as well as a rubber band, or as well as as well as an elastic band, what else stores energy? What else do we have a look at? Can you remember?
The spring.
Yeah, good job. So we had a look at springs. Thank you very much. Energy transfer means, Sophia? If I transfer energy to you, what is the energy doing?
Give energy.
Yeah, giving energy. So the energy, is it moving or changing?
The energy is transfer.
Yeah, I mean, you're not wrong. You're not wrong. It means, Sophia, the energy moves from place to place or from object to object. And then James is going to tell us what energy transformation is. James.
What?
What is energy transformation?
Energy transformation is when one energy changes to another form of energy.
Oh, perfect. Thank you very much. Yes. Energy type has changed, like from motion to sound energy. Good job. Okay, right, guys. What I want you to do is quickly, I'm going to ask you all to turn your microphones on. I'm going to read out a piece of vocabulary, for example, potential, and you guys all together are going to read out what it means. Okay, I'm just going to do it for a minute. Please don't shout. I totally know you're going to shout. Okay, everybody on mute. And I knew it. I knew it. Okay. Go on, get it out of your system. Get it out of your system. I'll give you 5 seconds. 5, 4, 3, 2, 1, and ready. All right, Kiddlywinks. What is a collision? Good job. What is energy transfer?
Energy moves from place to object.
Lovely. What is energy transformation?
Energy
Energy type is change of motion to sound energy.
Good. What is the verb to collide?
To hit,
Impact or crash.
And what is potential energy?
But it could be energy that motion energy.
Good job. And can you tell me what force acts on an what force acts on an object to pull it down to the earth? Gravity.
Gravity.
Yeah, a little scientist. Proud of you. Okay.
Gravity fruit.
Gravity. What?
Okay.
Okay. Oh, I've still got these dots on my screen for Viet Hong. Hang on. Thanks. Okay. So you remember this slide?
Look funny.
How do collisions show energy? Well, you tell me. How do collisions show energy? Why do I have bowling pins? What happens when the bowling ball collides with the bowling pins?
It falls.
What falls?
The pins.
Yeah, the pins fall down. Why?
I don't know.
Oh no, but I want you to know. This is why we're doing this. Okay. So the bowling ball, when it's moving, what kind of energy does the bowling ball have? Lisa?
The bowling ball will hit the pin.
The bowling ball will hit the pins. You're correct. When the bowling ball is moving, or when any object is moving, what kind of energy does it have?
Motion energy.
Yes. Good job. And I'm going to put you all on mute. Haha. Right. Yeah, it's got motion energy. Then something happens to that motion energy. It goes from the bowling ball into the pins. Now, is that a transfer or a transformation if it moves from the bowling ball into the pins? Can you tell me, Courage?
Yes.
Hey, Courage. Courage, if the motion energy moves from the bowling ball into the pins, is that a transfer or a transformation? If the motion energy moves, is that a transfer or a transformation? Pardon?
Transformation.
There might be a transformation if it makes a noise, and then it would transform into sound energy. But if the energy is just moving,
Transfer.
then it's a transfer. Good job. Okay. Yep, collisions show energy through energy transfers. When one thing hits another thing, then they move, or they change direction, or they speed up, or they slow down from the energy transfer. What will happen to the size of the collision if we input more or less energy? Okay.
Yes.
Hi, Ruby. What will happen to the collision if we hit it really, really hard? If we hit the pins really, really hard with the bowling ball, will there be a big collision or a small collision?
Is a big collision.
Good job. And what if we roll the ball very, very gently?
Is small collision.
Yeah, exactly. Okay, thank you. Is direction important? I want to ask Katie. Katie.
Yes.
Hello. Katie, have you ever been on the bumper cars
Yes.
at a carnival? Have you ever had somebody bump into the back of you?
Just in front or maybe
Oh,
right.
just in front. And how did it feel when you were in the bumper car and somebody hit you from the front?
Like it's like
Or show me what happened.
like I jump up a little bit.
Yeah. So the force of it, that's an energy transfer that's happening. So the energy from that bumper car went straight into you, and you went gadoosh. You were like, ugh. Now, if they'd bumped into the back of you, do you think you would have jumped up as high? Or do you think you would have moved forward?
I would move forward.
Yeah, you would have moved forward. So direction is important as well. Cool. Thank you, Katie. Is speed important? Vegetal Blue.
Yes.
Is speed important in collisions?
Yes.
Yeah. If you were driving the other bumper car and you hit Katie, if you'd hit her really fast, what would have happened to the collision?
More collision.
Yeah, greater collision, a bigger collision. What if you were moving very slowly?
Smaller collision.
Yeah, it would have just been like boop, and everyone would have driven on their merry way. Cool. Thank you very much. You don't need that game. Oh, but you can have this game soon. Soon. So, collisions, energy transfer, and transformation. Now, I've got a game ready to go for you guys called Traffic Collision. Yep. A game called Traffic Collision, and obviously it involves cars. Now, Myth, what do you think the point of the game is? What do you think you have to do in this? If you're right, I'm going to tell you now, you're the red car, okay?
The red car will hit the two black car.
Yeah, so basically you've got to drive along and you've got to smash up the other cars for points. You've got to collide with the other cars for points.
The car will lap.
The car will what?
Will break.
The car will break, exactly. Why? Why will the car break?
Because it hit very.
There might be some heat, but what if the car is moving very fast? If it's moving, what kind of energy does it have, Myth? Don't you turn off your microphone? I can see you. Right, Myth, if it's moving, what kind of energy does it have?
I don't
Motion.
know. Motion.
Good job. Okay. So I'm going to play, I think, about 30 seconds of this game to show you, and then I'll link it to you later on. And I want you to pay attention to energy transfer, which is how the cars get so smashed up, because the motion energy is transferring from the red car to the black cars. And the energy transformation, although you're not really going to hear it, it would make sound, but it's really loud. And I think I turned the sound off, I'm not sure. And then afterwards, we're going to answer these questions here. How do collisions show energy transfer? What happens to the cars? What can affect the size of a collision? You'll see that there's something that gives you a little boost, and that definitely affects how big the collision is or how many points you get. And what type of energy is involved in collisions? I'm going to ask you that at the end as well. Myth has just told us. And where's my link? What might motion energy be transformed into collision? I've just told you that as well. Share sound. click this thingy and share this. So, can you guys see my game screen? Yep, cool. Okay, so to start the game, I control the car by using the arrow keys. Please don't be too loud. This is definitely going to be too loud. Okay. I'm going to use the arrow keys to do it. The aim of the game is to get as many points as you can from colliding with the other cars. To get more points, you can use something called nitro, and that makes you move faster. Okay, these are all hints and keys. So I want to ask you guys some questions about the game. I'm literally just talking until somebody else gets back to me to say they can hear me. Yeah, you guys can hear me. Sweet. Okay. So now you can hear me, but you couldn't before. Why? Why couldn't you hear me? It's to do with the game. I mean, yes, there was lots of background music, but as well as the background music, there was something else as well. Vegetable Blue.
Yes.
Hey, what happened when the red car collided with the black cars?
The black car and the red car crash.
Yeah, they crashed. They took damage. What is that? What's that due to? What causes that?
The red car hit the black car.
Yeah. So what does the energy do from the red car?
The energy transfer from the red car to the black car.
Exactly. Good job. So the energy transfers from the red car to the black car. Let me ask somebody else. Maradona. Okay, Maradona's not listening. What about Ruby?
Yes.
Hey, Ruby.
Yes.
When the red car collided with the black cars, it did some damage. Could you hear anything when they collided?
Yes.
Yeah. So if the motion energy is changing into sound energy, what do we call that? An energy what? When the energy type changes. I'll give you a clue. It's kind of like this bit down here.
Energy transformation.
Yeah, good job. So when the motion energy is transformed into sound energy, that means we can hear the sound of it colliding. We can hear it hitting. Good job. And thank you, Ruby. I wonder, can anybody tell me, let me clear that. What can affect the size of a collision? Neymar. Hey, Neymar, can you tell me one thing that can affect the size of a collision? Did it matter how fast the car was going?
No. How strong the car hit?
Yeah, so that would be that would be the collision, the size of the collision, how hard it hits it. What about speed?
It's fast.
Yeah, so if it goes fast, then what happens to the collision? Big collision or small collision?
Big collision.
Yeah, good job. Okie dokie, thank you, Neymar. I want to ask Goku. Hello, Goku. Goku, what happened when I hit the cars from the front, when I hit them straight on? What happened to my car?
Your car will not broke.
Yeah, my car died. I got broken. I got smashed up. So is the direction important? Yes. Yeah. Oh, okay. You put your thumb up. Yeah. Good. So the direction is important as well. Good job. And the last one I want to ask is a bit trickier, but it just ties everything else in that we've been learning about. How do collisions show energy transfer? I'm going to try Maradona one more time. Maradona, if you can hear me, can you, yeah, are you there?
Yes.
Good job. Okay, so Maradona, having looked at the game and everything that we've studied about so far, how do collisions show energy transfer? What happens? What does the motion energy do?
Transform.
If it's going to, it might transform, but we're looking at transfer at the moment. So what did the motion energy in the red car do to the black cars?
Hit the black car.
It hit the black car. Good. So what's that called when it moves from one object to another one?
Transfer.
Transfer. Yeah, good job. Okay. Nice. What have we got next? Oh yeah, so this is just a recap. These are the slides that you saw on speed. And I'm going to turn everybody's microphone on and you're all going to shout. And I'm going to give you 5 seconds to shout and just be excited. But I want you to just read the points on speed all together. Ready? And okay, turn your microphones on, please.
The faster something moves, the more motion it has.
Good job. Everybody.
Energy it has. The faster something moves, the more motion it has.
The faster something moves, the more motion it has.
The faster something moves, the more
energy transfer, the more energy transfer, the bigger the collision.
The more energy is transferred, the objects are hit.
Good job.
The object shows the amount.
Good job. Okay, so everybody, the more energy it transfers. Finish that sentence. The more energy it transfers. Collision. The bigger the collision. 1, 2, 3. The more energy.
More energy to the object they hit.
The bigger the collision. Thank you. Okay.
Energy to the object that hit. The speed of an object can show the amount of energy the object has.
Good job. Is that David?
Yes.
Yes. Good. Yep. So that's what we did when we looked at that slide. We also had a look at size and collisions. What happens to a collision when two small objects collide? If two small objects hit each other, big collision or small collision?
Small.
Good job. What about when two large objects collide?
Big collision.
Big. And what are these blue things that I've drawn underneath? Particles. Good job. Because how does the motion energy transfer? Through the
Motion energy transfer from
the particles.
Good job. So a large object, does that have more particles or fewer particles? More. Good. And if it's got more particles, it can have more what?
More collision.
More collision, yes, but more energy. Nice. Okay. The greater the speed, the greater the collision. Everybody, the greater the speed, the greater the collision. 1, 2, 3.
The greater the speed,
The greater
the collision.
Wonderful.
The greater the particle, the greater the
Nearly.
size, the greater the collision.
Yeah, the greater the size, the greater the collision. Nice. Okay. Right. Nice.
Nonsense.
And energy.
Nonsense.
And Oh, peace and quiet. Okay, mass and energy. You've done this one already. Hurricane, you missed this, but we were looking at the relative mass or weights of the balls. We've got a foam ball, a baseball, and a steel ball. What we had to do was decide which ball will travel the least distance, the middle distance, and the greatest distance, because as much as speed and size are connected to collisions, so is the mass of an object. And that's why we were looking at the particles, the little blue circles underneath the cars. Now, I do believe I want you to circle. Yep, circle time. Aha. Hello, Ace. Nice for you to join us. All right, Kiddlywinks. What I want you to do, I'm going to turn on annotations and I want you to circle the ball that you think will travel the greatest distance. Okay? Okay, so drawing is on.
Okay.
I want you to circle the ball that will travel the greatest distance. Everybody. Beautiful. Okay, and stop. Let's have a look. Yes. Okay, so the foam ball travels the greatest distance. Can anybody tell me why? Going down, do you know? Why will the foam ball travel the greatest distance?
Because it was the lightest.
Yeah, because it's the lightest. Exactly. Thank you. Okay, I'm going to clear that. Next, I want you to circle the ball that will travel the middle distance. You got it?
Yes.
Kena kurang kuahnya mah.
Good. So we're circling the middle one. Oh, someone's getting fancy. Yeah.
Yeah.
What is the question?
The question is, can you circle the ball that will travel the middle distance? We've done the greatest distance. That was the foam ball because it's the lightest. Yes, good. And stop. Yep, so you guys have all clicked the baseball. The baseball. And you are correct. So the baseball travels the middle distance. You can tell me why. Who can tell me why? What can you tell me about its mass or its weight? The baseball. Can you turn your microphone on? Myth. Why does the steel ball travel the least distance? Do you think it's heavier or lighter or the same?
It's heavier.
Yeah, it's heavier. So because it's heavier, it takes more force, it takes more energy for the spring to push it. Good job. Done that one. Moving the stuff all around the screen. So stored energy, potential energy. Ace, where are you? Hey, Ace. So, Ace, can you tell me anything about stored energy or potential energy? And you can use these pictures to help you.
Store energy is chemical energy.
Chemical energy. Now,
Store motion energy in it.
Yeah, good job. So chemical energy is a form of stored energy, but stored energy is not necessarily chemical energy. For example, all cats are animals, but not all animals are cats. That way around. Okay. So what can you tell me about a rubber band?
A rubber band, when we stretch it stored motion energy in it, and when you release the rubber band, it releases the motion energy.
Exactly. Good job. Or it releases the potential energy as motion energy. Good job. And thank you, Ace. I want to ask Lisa. Hey, Lisa, I want to ask you about the plates. Lisa, why do the plates have potential energy?
Because the plate is so heavy that if the man could trip over something, the plates could fall down. So that when the plates have not fall, it stored potential energy.
Good job. And what force makes them fall down?
Motion. Gravity.
Good. Yes, good. So gravity acts on it. Gravity is the force, and then motion is the type of energy. Thank you very much. And so rubber bands store energy when you stretch them. Plates have potential energy at a height because of gravity. Can someone tell me about the spring? What do we do to the spring? Ruby?
Yes.
Hey, Ruby. So how do we store energy in a spring? What do we have to do to it? Do we stretch? Yeah, I was going to say, do we stretch it or do we compress it, push it down? Do you remember that word? Compress?
Yes.
Yeah. Okay, so yeah, so we have to squeeze the spring, push it to make it store energy. The roller coaster. Let's do this one quickly with Goku. Hey, Goku. So do you remember this roller coaster picture?
Yes.
Yeah. So when does it have energy and how do you know? So Goku, we know it's got motion energy when we can see it moving. But when does the roller coaster have potential energy? So potential energy is when gravity wants to pull it down. Where on the track do you think it has potential energy?
I think it has potential energy because when the roller coaster goes at the middle of the roller coaster, it has like a wheel, so the wheel
And keep it moving.
keep it moving,
Good.
and the wheel will
Yeah, the wheel will help it move along the track.
yes.
But so I've turned on annotation again, and I want you to just use a dot or a star. I want you to make a dot or a star on the point of the track where you think the roller coaster has potential energy. Good job, Via Hung. Right, so it's at the top of the track. At the top of the track, that's when the motion energy it's been used up. Okay, it's got no more motion energy, and gravity, which acts on it all the time, gravity can now overtake. Gravity is now stronger than the amount of motion energy. So at the top of the track, it's going to start pulling it down, and that's when it's got motion energy. And you can stop that. Cool, thank you very much. I did say a point or a star, but lovely arrows, guys. Okay, there we go. And I want you guys to read this out loud to me. I want you to read out both of these points, actually. So we know it has motion energy.
We know it has energy
And has potential energy.
We know it has no energy when we can see it moving. It also has potential energy it's looping one pull it down.
Good job. Okay.
At the top, it's gravity to roll it down.
Yeah, because gravity wants to pull it down. Now we've only got a couple of minutes left, which means that the next exercise I'm actually going to save for tomorrow.
No.
What did Jake do? I know, it's very exciting. Look. Oopsies. How exciting. Put the actions in order. No, I want you to do that tomorrow. What I like to do, actually more important is
No.
Oh, I do need to send you the game. I'll tell you what, if you answer a couple of questions, I'll send you the link. Okay?
Where will you send with the game?
Right, guys, what is a collision? Everybody, what's a collision?
Collision is
An impact
or crash.
Yeah, an impact is a collision or crash. What is potential energy?
To it, impact or crash energy.
Storage energy can become motion energy.
Good. What is energy transfer?
Energy moves
Cái này con xem mẫu rồi.
from place to place or object to object.
Good. Everybody, tell me, what's energy transfer?
Energy moves from place to place or object to object.
Good. What is energy transformation?
Energy that is changed like from motion to sound energy.
Good, it's when it changes. Okay, so I've sent you guys the link for the game.
Wait me a minute. I need to copy it down.
Okay. You should be able to, can you highlight it? Can you drag it with the cursor and then copy and paste it into the browser? There's Alex's spaceship. Okay, so tomorrow we're going to do a quick review on cause and effect. We're going to do the Jake slide because that's also actually that order of events. But thank you very much, everybody. Good reviewing.
Goodbye.
Good revision. Goodbye. Enjoy the game.
Bye.